All right, so whether you're adding or subtracting, it's going to be the same process, okay? So the main steps. So let's say that we have the problem 2 times 10 to the 4th, and we're going to add to that 3 times 10 to the 5th power. Now, the difficult part about this is the only way to actually add these numbers is if our base of 10, if they have the same exponent, okay? So your power of 10 must have same exponent. So you can see this has a 4 and that has a 5, meaning they don't have the same exponent. So before we add anything, we need to change this so that they do have the same exponent, okay? And this is how we're going to do that. We're going to take the biggest exponent and we're going to change the biggest exponent to be the smallest exponent. So if I want to change a 5 to a 4, what do I need to subtract from it? A 1, okay? So if I need to subtract a 1 from the exponent, then that means I'm going to move this decimal, 1 space to the right. Okay, so again, the reason that we're moving it 1 place is because we have to subtract 1 from 5 to get 4, so it's the same as over here. So this is going to become 10 to the 4th power. And when I move that decimal, the decimal is currently 3 point, right? It's right here. When I move that decimal 1 place over to the right, it becomes a what? A 30. A 30. Okay? So before I do anything else, I'm going to pause and see if you have any questions about that step. Okay, so once again, the reason that I moved it is because this exponent and this exponent have to be the same. So my biggest exponent is the one that I'm going to change. And to change a 5 to a 4, I can subtract 1. And since I'm subtracting 1, I need to move my decimal 1 space, and we're moving it to the right. So it started out right behind the 3, the decimal did, and when I move it 1 space, now that 3 is becoming a 30. Okay? All right, I'm going to scoot up a little bit because this now is my new problem. So the next thing that I can do, now that my base 10 powers are the same, now I can add the numbers that are in front of that multiplication sign. So I'm going to add 2 plus 30, which is 32. Okay? So that would give me 32 times 10 to the 4th. I just keep that base, that power. So I can even put that in there. Stays the same. So again, because my 10 to the 4th, they both had a 10 to the 4th, that allowed me to do 2 plus 32 to get 32. And then I just kept my 10 to the 4th in my answer. The last thing that we have to do, we should be somewhat comfortable with doing, because we've had to adjust before, where this is not in correct scientific notation. Because remember, in correct scientific notation, our decimal has to be between the first and second digit. Right now, the decimal is after that 2, so we need to adjust our answer. And as a reminder, when you adjust your answer, if we're moving 1, which is what we need to do here, right? We need to move 1 right, or sorry, that's left. 1 left, then I need to add 1 to my exponent. So this is going to leave me with the final answer of 3.2 times 10 to the 5th power. Now you may be thinking right now, I have no idea what she just did. Don't worry. I have plenty of examples, okay? And it's the same steps over and over and over and over again. So we're going to do more examples. I don't expect many of you to already have it, okay? Don't worry. What do we do with the second one? Well, we added our 2 and our 30. So now there's just one answer. There's not 2 different things. Okay? So 2 times 10 to the 4th plus 3 times 10 to the 5th is 3.2 times 10 to the 5th. Okay. Don't worry. It's going to be okay. We're going to do another one. We have multiple ones to do. All right, let's try another one. So let's write the problem 2 times 10 to the 3rd plus 5 times 10 to the 5th. Now, if you remember me saying on the last one, we want to change our biggest exponent to be the same as our smallest exponent. So our smallest exponent is a 3, and I want to change my exponent of 5 over here to a 3. So what do I need to subtract from 5 in order to get 3? 2. Okay? I need to subtract 2 from the 5 to make it a 3. That means I'm going to move the decimal 2 places. Move decimal 2 places. And I'm moving my decimal to the right. So this 5, when I move it 2 places, is now going to become a 500. So I'm going to rewrite my problem. Again, my first number didn't change, 2 times 10 to the 3rd. But my second number is now becoming 500 times 10 to the 3rd. Let me take questions before I move on to the next part. Do you understand why I chose 2? Why I moved it 2 places? Tommy? 5 is 2 more than 3, right. So that's where that 2 is coming from. I'm not just kind of making it up. I needed to change the 5 to a 3, so I had to subtract 2, which means I needed to move it 2. I think it's going to be very helpful if you have these notes that I have in green written in your notes, especially about the direction to move your decimal. That can get confusing. Sometimes it even gets confusing for me. So it helps to have those notes to refer to. I think once you get to this step, then the rest of it is easier, okay? I think that first step is the most confusing. So now that we have this step, we're going to add the numbers that are in front of the multiplication sign. So 2 plus 500 is 502. So my answer right now is 502 times 10 to the 3rd. Okay? But I'm not finished because it's not in correct scientific notation. Because right now, this decimal is after the 2, and I need the decimal between the 5 and the 0, don't I? So how many places would I need to move it in order to make that happen? So 2 left means I'm going to add 2 back to that exponent. So it'll give me 5.02 times 10 to the 5th power. You feel a little bit better about that one? Little bit better. All right, let's try a subtraction problem. Okay, let's try a subtraction problem. Let's do 7 times 10 to the 8th power minus 4 times 10 to the 6th power. So again, I always want to change my exponent that is my biggest exponent. I want to make my biggest exponent the same as my smallest exponent. So my biggest exponent is the, which one? The 8. The 8 is the biggest. How many would I need to subtract from 8 to get 6? 2. So 2 tells me also to do what? Move it 2 places. Okay, so again, 8 minus 2 is 6. So we need to move the decimal after the 7 2 places right. Okay? So when I change a 7 point and I move it 2 places, this now becomes a 700. So 700 times 10 to the 6 minus 4 times 10 to the 6. Now the only difference with this problem is that instead of adding the first two numbers, we're going to subtract them. That is the only difference in the adding and subtracting rule. So what is 700 minus 4? Hopefully you can do that in your head. 696. So we get 696 times 10 to the 6th power. But we need to adjust our answer by moving the decimal how many places? 2 places back, 2 left. So I'm going to add 2 back on to my exponent. 6.96 times 10 to the 8th. Okay, so hopefully you're feeling a little bit better about that. I'm going to give you one now to try on your own, because sometimes that's when it makes sense and then you try it on your own and then you get stuck, okay? So why don't you try this one on your own, please? This is also going to be a subtraction problem. I'm going to pause the video so you have time to work. Alright, so in this problem, how many places do I need to move it at first? 1 place, because I need to change my 8 to a 7, and 8 minus 1 is 7. So in this 4, I only need to move it 1 place, so my 4 is going to become a 40. So 40 times 10 to the 7th power minus 9 times 10 to the 7th power. So now I'm going to do 40 minus 9, which is 31. So that gives me 31 times 10 to the 7th power, which I then need to adjust because this decimal needs to go in between the 3 and the 1, which means I'm going to add 1 back onto my exponent. 3.1 times 10 to the 8th power should be your final answer. Raise your hand if you got that right. Good. Most of you did. Most of you did. All right, let's do one more, and then I'll be done, okay? One more. It's going to be an addition problem. So be very careful when you're doing these that you're paying attention to, am I adding or subtracting? So you can see in this one, I just put some decimals or some numbers after my decimal. It does not change the way we do this, okay? How many places do I need to adjust at first? How many things do I need to take off my exponent? 2, because I want it to be a 4, so I'm going to take 2 off, so I'm going to move this decimal 2 places. Now, in the other problems that we've done when we've moved it, we've just added zeros in there. We don't need to do that this time. This 4.26 is going to become a 426 times 10 to the 4th. I don't do any adjusting over here at all. So now when I add, and I can still, hopefully everyone in here can do this mentally, 426 plus 3.15, you're really just adding that 6 and the 3 to get what? 429.15, correct? Times 10 to the 4th. And we still would need to adjust it so that our decimal is between the first and second digit. So that's moving it over to the left 2 places, which means I would need to add 2 back onto my exponent. So final answer, 4.2915 times 10 to the 6th. So it wasn't really any different at all, was it? No. I just didn't want you to get your assignment and see a problem like that and be like, hey, we didn't do one of those. So now we did. And you can see it's the same exact steps. All right? Any questions before I give you your assignment? Okay, you have 10 of them. 5 of them are adding, 5 of them are subtracting. So make sure you're really paying attention if you're adding or subtracting.